So if our goal is to count the number of atoms in a unit cell, we need to think about a model of the unit cell. So here in this primitive unit cell, we have 8 atoms at the vertices of our unit cell. Now, to count the atoms, we're only interested in the atom part that is inside the unit cell. So really, only a fraction of each atom is inside this unit cell. And if we imagine that the atom is cut in half in 1, 2, 3 dimensions, so 1/2 times 1/2 times 1/2, that means that only 1/8 of each of these atoms is inside the unit cell. So if we want to add up the total number of atoms in a primitive unit cell, we have 8 atoms, each with 1/8 inside the unit cell, for a total of 1 atom inside the unit cell. If we think about the body-centered cube, we still have the 8 atoms that are at the vertices of the unit cell, so we know that they'll overall contribute 1 atom. We also have the 1 atom inside the unit cell, and so the whole thing is inside the unit cell. So in a body-centered cube, we have 2 atoms. In a face-centered cube, it looks a little more complicated, but it'll be okay. We have the 8 atoms at the vertices that represent 1 atom inside the unit cell. We also have 6 atoms, 1 on each of the faces. Now on the face, each of those atoms is cut in half by the plane of the unit cell. And so half of each of those atoms is inside the unit cell. Half is inside, and the other half, the other hemisphere, is outside. You can see it there, so half is inside. So if we have 6 atoms, and 1/2 of each is inside, that's a total of 3 atoms, plus the 1 inside produced by the vertices. So a face-centered cube has a total of 4 atoms inside the unit cell.